What's up everyone, Patrick here, welcome back. Moving on to another video dealing with factoring special cases of either a difference of squares or a perfect square trinomial. We're going to have to factor all of these expressions over here. So we've already done a couple of special cases in the video before. This is kind of like a part 2 where we first have to see, are we going to be working with a difference of squares or a perfect square trinomial? Hopefully by this time you're pretty comfortable noticing that. So for example here, that's going to be a difference of squares. That right there is going to be a perfect square trinomial, difference of squares, etc., etc. Just noticing the different formats. And then from there, depending on what case you have, there's going to be different processes for factoring. But first is recognizing what you're working with. So let's start off with part A. We got 9 bracket x minus 6 squared minus 49y squared. So as I mentioned here, we're dealing with a difference of squares. Remember, what is the difference of squares formula? Well, if you got something in this format, it factors into a minus b, a plus b, like that. And so what we want to do is try to take this and write it in that format right there. Now, first thing we always check, can we factor something out? So with these two expressions, can we take something out? Well, with the 9 and 49, there's no common factor between those. So we can't do that. So let's see if we could take this and rewrite it in this format. Now over here, be careful because this isn't in this format. Notice we need a bracket, something to the power 2. Here we do have something to the power 2, the x minus 6, but notice the 9 is not to the power 2. And basically we have to have an entire expression. We have to represent this as an entire expression in brackets to the power of 2. So how can we do that? Well, we can rewrite this as 3x minus 6 in brackets to the power 2. Because remember, with exponent rules, if you're multiplying two expressions and then you have an exponent, then basically that exponent is going towards both of those expressions. So like over here, it's like you're multiplying the 3 and the x minus 6, so applying that rule, you'd end up with 3 to the power 2, x minus 6 to the power 2, which would give you 9 bracket x minus 6 to the power 2, which is what the original expression was over here. So we've got to take this, rewrite it like that. Now, if there was no 9 over here, we did that in the previous video, then we would just have already x minus 6 to the power 2, and that would just be the a value. But this 9 over here, we got to also incorporate that exponent to this 9. And the way we do that, we change it to a 3, and then put everything in brackets to the power 2. And now it's like we have a to the power of 2. Okay? This 49y squared, same thing. The y is to the power 2, but the 49 isn't, so we could rewrite this as 7y to the power 2. 49y squared and 7y to the power 2, both of those are the same thing. And so from here, we can tell that this is now in a squared minus b squared format. So the a value is 3 bracket x minus 6, and then the b value is 7y. And so what does this factor into? Well, a minus b, a plus b. So this value, 3x minus 6, minus the b value, which is 7y, 3 bracket x minus 6 plus the b value, which is 7y, like that. And then to simplify this, you can distribute inside the bracket, and you end up with that, and you end up with that right there. And you could rearrange it maybe if you want in a nicer format. So let's actually write the final answer here. If you want to put the y over here and then the constant at the end, so you could write 3x minus 7y minus 18 times 3x plus 7y minus 18, whichever way you want to leave it in. It might be actually better to leave it in this format so you could see both of those terms, like the a value minus the b value, the a value plus the b value. So whichever way, maybe a textbook will give this type of format or this type of format, they're both the exact same thing. So that's what it's going to factor to. Okay, moving on to part B, we have 4 bracket 2x plus 3 squared plus 12 bracket 2x plus 3 plus 9. So whenever you get something like this, again, we've done questions like this before where you notice you're dealing with a bracket like that, the same bracket. What we can do is we could let m equal 2x plus 3. So then we could rewrite this as 4m squared plus 12m plus 9, like that. And now notice we're dealing with just a quadratic. We could factor that quadratic and then bring that 2x plus 3 back. So if you do this by decomposition, 4 times 9 would give you 30. So let's actually go in order. Sorry, I was jumping ahead there a little bit. But what I want to get is the AC value, which is 36. So what two numbers multiply to 36 add up to 12? It's going to be 6 and 6, right? So we know we're dealing with a perfect square trinomial. Then from these two, we could take out a 2m, and we'd be left with 2m plus 3. Then from these two, we could take out a 3, and we're left with 2m plus 3. 2m plus 3, and then we got that 2m plus 3, right? So this here, it ends up factoring into 2m plus 3 squared, like that. Okay, another thing you can notice, you're dealing with a perfect square trinomial here because we could take this expression and we could rewrite it as 2m squared. Then the 9 we could rewrite as 3 squared. And remember, with a perfect square trinomial, let's actually write, let me sort of single out these formulas. So I'll write the perfect square trinomial formula here. Okay, that's going to factor into a plus or minus b squared, like that. So from here, because we took this, wrote the first term as a squared, so notice that the a value would be 2m, the b value would be 3, and then we'd have, because we're dealing with a positive case, plus 2 times the a value of 2m times that b value of 3. Notice 2 times 2m times 3 would indeed give us that 12m. So that would factor into that a value of 2m plus that b value of 3 squared. So you could also do it with the formula. With all of these, I'm going to be using the decomposition method. But for this one, I'll bring back this formula if you want to use it to factor. If your teacher expects you to use it, that's how you can set it up. Okay, whichever way you do it though, this is going to factor into that. But remember that we don't want our answer in terms of m because our original is in terms of x. Remember, we let m equal 2x plus 3. And so what we got to do is we got to take this, plug it in for the m value. And so we'd have 2 times 2x plus 3 plus 3, and then that's going to be squared. The fact that this and this are similar, 2m plus 3, 2x plus 3, that's just a coincidence, right? This bracket could have been anything. It could have been like 3x minus 1, and then we'd be plugging in 3x minus 1 over here. So it's just a coincidence in this case that they're the same. And so over here, distribute 4x plus 6 plus 3. That's going to be squared, which would give us 4x plus 9 squared, like that, right? So this ultimately ends up factoring into this over here. So first we plugged in or substituted a new variable m for this bracket, brought that variable in, then took this, factored it, and then brought that original expression that we took out, brought it back in order to make our final answer in terms of x. Now moving on to part C, we got 5x minus y squared plus 8 bracket y minus 5x plus 16. So in this case, notice that we're going to be applying the same method because we're dealing with brackets here, but notice that at this point right now, these brackets are not exactly the same. So we can't just say let m equal this 5x minus y, because then we can't plug in this m over here, okay? Because 5x minus y is different than y minus 5x. But what we could do is we could take this bracket and we could write it in terms of 5x minus y. So if we have y minus 5x, what can we do? We could take out a negative 1. We could factor out a negative 1. What would that do? It would change all the signs. And so we'd end up with negative 1. If we rearrange these, we end up with 5x minus y. So y minus 5x, this bracket, or that expression, is the same as both of these brackets multiplied. Right? After we take out a negative 1, we end up with 5x minus y. So what we can do is, let's continue this over here. We'll have 5x minus y squared plus 8. Now instead of this bracket here, I'm going to write it as a multiplication of those two brackets. Like that. And then we got the plus 16. Right? So sometimes you got to look for these sort of cases where you got to do a little bit of preliminary algebra in order to get to a certain format that you can work with. And now over here, notice what is it going to simplify to? We'll have 5x minus y squared. 8 times negative 1 is negative 8. Then we got 5x minus y plus 16. And now, notice we got the same bracket. Now we could bring back that m value. So we'll have m squared minus 8m plus 16 like that. Okay, and now we can factor this over here. This is actually going to factor into a perfect square trinomial. I'm not going to go through all the steps. At this point, you should be pretty comfortable factoring something like this. When you do the decomposition, it's going to end up with m minus 4 squared like that. And then we bring back that 5x minus y, plug it in for the m, so we end up with 5x minus y minus 4 squared, like that. That ends up being the final answer, right? So I feel like it's easier to do it this way than expand everything and then try to factor it into that. That's going to be a lot tougher in my opinion. So final answer for this ends up being 5x minus y minus 4. And then that's going to be squared like that. Moving on to the next one, we got 36 x to the 4 minus 225 y to the 6. So hopefully at this point you could tell we're dealing with a difference of squares here. But what we want to do, we want to try to rewrite this in this format where we're going to have something squared minus something squared. So what can we do? What's the square root of 36? 6. The square root of x to the 4 is just x to the 2, right? Because notice x squared squared would give us x to the 4. It's like we're taking this and dividing it by 2 to get that. And then 225, the square root of that is 15. Y to the 6, if we take out this 2, over here it's like we're taking the 6, dividing it by 2, which would give us y to the 3. Okay, so one more time here. Remember, when you're multiplying two expressions, just to kind of go backwards here, it's like you're taking the expressions to that exponent on the outside. And we'd end up with 36 x to the 4, which is this. So it's like we went backwards this time. Same thing with the 15, y to the 3. If we square that, notice we're multiplying the 15 by the y to the 3, so it'd be like 15 squared, y to the 3 squared, which would give us 225 y to the 6, which is what we had right there. Okay, so we took this, rewrote it like that. And be careful with these exponents. When you're taking this and rewriting it with an exponent 2, you got to take those exponents, basically divided by 2, because over here you're going to be multiplying the exponents. Right? So to go the other way, you gotta divide the exponents in order to get this. So if this was like x to the 10, this would end up being x to the 5 right there. Okay, and now notice it's in that a squared minus b squared format. It's in that format where the a value is 6x squared, the b value is 15y cubed. And so what are we going to end up with? Let me actually write the answer here. We're going to end up with a minus b, so 6x squared minus 15y to the cubed, a plus b, plus 15y to the cubed. So that ends up being the final answer. Something you also want to check for, a lot of times, sometimes these brackets can factor further, especially this one where we got this negative. A lot of times this will be a further difference of squares. We're actually going to see that in these future examples in this video. In this particular case, this is not a difference of squares. You can't take the square root of 6, can't take the square root of 15. So we can't take those and rewrite it as brackets, the difference between brackets squared, right? But if you were able to factor that, then that could factor into 2 extra brackets. We're going to, again, see that soon. I think actually in the next example, that's going to happen. But in this particular case, you can't factor it further, so that ends up being the final solution. Now moving on to the last 3, so we got part E, so we got, let's write it, I'll write it over here. So we got 16x to the 4 minus 81. So again, hopefully you could tell by this point, which of these cases are we dealing with? We're dealing with a difference of squares. And to rewrite in that format, what we want to do, we want to rewrite these like that. And so we could take this, we could rewrite this as 4x squared squared, and then the 81 we could rewrite as 9 squared like that. Okay, so we could tell here the a value, if we compare it to this formula, the a value is 4x squared, the b value is 9, and that's going to factor into a minus b, a plus b. So we'd end up with 4x squared minus 9, 4x squared plus 9, like that. But notice here, this is not the final answer, because the 4x squared minus 9, we can actually factor that further, because that's a difference of squares. So we could rewrite this as 2x squared minus 3 squared, a squared minus b squared, and so that's going to be a minus b, a plus b. Right? So always check, can you factor the brackets further? This bracket, we could further factor into these 2 brackets. So I'll write those 2 brackets. And then that final bracket of 4x squared plus 9, you can't factor that further. If you want to check 4x squared plus 9, okay, this is like 4x squared plus 0x plus 9. So notice that the a value is 4, the b value is 0. And then the c value is 9. So what 2 numbers multiply to the AC value, which is 36, and add up to 0 to the b value? There's no numbers here that would work out, right? Negative 6 and positive 6 wouldn't work. Negative 6 plus positive 6 would give us 0, but negative 6 times positive 6 would give us negative 36. Right? If this was minus 36 or minus 9, as we showed already here, then it factors further as a difference of squares. But because there's this plus here, this AC value is positive, it's not going to work out. There's no 2 numbers that are going to satisfy that. So that 4x squared plus 9, it actually doesn't factor further. And that's usually the case. It's usually this bracket that can potentially factor further. Not always, like in the previous example, but sometimes it can. Like in this case, this factors into those. Basically, if you could take the square root of those, then you know you're dealing with a difference of squares. Okay, so that is the answer to part E. Now, part F over here, this is kind of a weird format, but this is actually a perfect square trinomial. And the way you could tell is if we try to take this and rewrite it in this format, so first thing we would do, we'd have to rewrite this first value as something squared, right? Because we have that a squared at the beginning. What's the square root of 16? 4. What's the square root of x squared? It's just x. Square root of y to the 4, it's y squared. Like that. So this first term is the same as this entire expression, right here. It's like we just took out that exponent 2. And then let's not worry about this middle portion, but then this 49, how do we write that as b squared? We could write that as 7 squared. Let me actually put it further over here. So with the n terms, notice that the a value is 4xy squared. The b value is 7, right? A, b, and then because we have a negative here, let's see if we get that middle term that we're looking for. So minus 2 times the a value, which is 4xy squared, times the b value of 7. What happens when we multiply these? Negative 2 times 4xy squared would give us negative 8xy squared, times 7 would give us negative 56xy squared. So because we were able to take this and write it in this format over here, it's a perfect square trinomial. Because there's a negative here, we're dealing with the negative case. Because there's a negative here, we're dealing with the negative case, so it ends up being a minus b squared, which is 4x y squared minus the b value of 7 squared, like that. So that ends up being the final answer. Okay, so that's if you use the formula. I know I said that I wasn't going to use the formula anymore earlier, but I did want to apply it in this case. Again, just because this is more complex, and in case your teacher expects you to apply that formula, you can. Now, if you're not going to use the formula, if you're just going to use decomposition, you can actually do that as well. So first thing you check, can you factor out something? Notice between the 16, the 56, the 49, can't take anything out. And so with decomposition, the a value is 16, the b value is negative 56, and then the c value is 49. And so from here, what's the AC value going to be? It's going to be 784. And so what two numbers multiply to that AC value of 784, but add up to that b value of negative 56? Well, it's going to be negative 28. It's going to be negative 28. Right? So the fact that we got the same number over here, we could tell it's going to be a perfect square trinomial. But again, doing the full work here, this one's going to be a little bit tougher. Remember, when you're decomposing this b value, keeping the same exponents over here, xy squared, and we got the plus 49. So all we did was we changed that b value to those two right there. Now, same thing, we factor by grouping. So what can we take out of these two? Well, between the 16 and the 28, we could take out a 4. We got x squared, x to the 1, so we could definitely take out an x. And then we got y to the 4, y to the 2, we could take out y to the 2. We could always take out the lowest exponent if that variable is common in all the expressions. So from these two, we could take out this. What would we be left with in brackets? What's this divided by 4x y squared? 16 divided by 4 would give us 4. X to the 2 over x to the 1 would give us x. Y to the 4 over y to the 2 would give us y to the 2. Minus this, we're going to divide again by what we took out. 28 divided by 4, 7. X, x, those cancel out. Y to the 2, y to the 2 cancel out. So it just ends up being 7, like that. Just be very careful with the algebra here. Now, there's a negative here, so we're definitely going to take out some kind of negative value. Between 28 and 49, greatest common factor would be 7. Okay, what's this divided by negative 7? Okay, one more thing, sorry, is the variables. There's no variables here, so we can't take out any variables. So we could only take out a negative 7 from both of these. So what is this divided by negative 7? It would just be 4x y squared. 49 divided by negative 7 will give us negative 7, like that. And then notice this bracket is the same as expected. And then what are we left with the remaining bracket? 4x y squared minus 7, like that, right? And then that ends up being the same bracket, so it's just squared. So we got it using the formula, or we got it with decomposition. So whichever way your teacher wants you to do it. Maybe there's another way they want you to do it. I can't think of really any other way besides, yeah, I don't know. Maybe there's some kind of, there's other shortcuts you could use, which I don't like because it's tough to apply in all situations. This decomposition process basically works in all situations. So whichever way you're doing it, just make sure that you're getting that final answer from this expression. That's what it's going to factor into ultimately. And then we got part G, 16 over 625 x to the 4 minus y to the 4 over 81. A couple of things I want to mention here with the format. This here could have also been written like this. And this here can also be written as 1 over 81, y to the 4. Right? So this are the same, this and this are the same. And personally, what I like to do is I actually like to separate the fractions from the variables. So I'm actually going to take this and rewrite it. Let's do it over here. So 16 over 625. X to the 4 minus 1 over 81 y to the 4, like that. Okay, so here, difference of squares. Now, how can we take this and rewrite it in brackets squared minus brackets squared like that? Well, let's say we had like, let's say we didn't have this 625, we just had 16 x to the 4. How would we rewrite this as something squared? Well, we would just take the square root of the 16, which would be 4. Square root of x to the 4 is x squared, right? We're just dividing that by 2. So this and this are the same. Same thing, it's just you got to square root the denominator as well if you're working with a fraction like this. So square root of 16, 4. Square root of 625 is 25. Square root of x to the 4 is x squared. Square root of 1, 1. Square root of 81, 9. And then we got the y squared like that. Right? Because if we just look at 4 over 25, if we take that to the power 2, remember that's like the numerator to the power 2. Remember your exponent rules, which would give us 16 over 625, like that. Right? Or the 1 over 9 to the power 2 would be like 1 to the power 2, 9 to the power 2, which would give us 1 over 81, like that. Right? So we're just square rooting the denominator as well. And now we got it in that a squared minus b squared format. And that factors, we know, into a minus b, and then we'll have a plus that b, like that. Okay, but what do we always check? Can we factor further? And this actually does factor further. This here doesn't factor further. This is not a difference of squares, but this is a difference of squares because we can take the, let's write it over here, the 4 over 25x squared minus 1 over 9 y squared, like that. We could take this and rewrite it as 2 over 5x squared minus the 1 over 9 we could rewrite as 1 over 3 y squared, like that. And then this is a squared minus b squared, so that factors into 2 over 5x minus 1 over 3y, a minus b, a plus b, like that. Right, so this one's pretty complex. So again, it's just going to take a little practice for you to see these, and maybe your teacher's not even going to do something complex like this. These are fairly complex factoring problems, but in case maybe they put it on a test or you run into it in homework, I don't want you getting super surprised with this, so I did want to go over these fairly tougher expressions. So they look a little bit intimidating initially, but with practice, hopefully after this video, when you see it, you'll be able to relate some of these to maybe ones in your homework and then know what the process is for factoring. Okay, so the final answer for this bracket, we were able to factor into these two brackets. So we end up with 2 over 5x minus 1 over 3y, 2 over 5x plus 1 over 3y, like that. And then this bracket, we couldn't factor any further, so that bracket just stays as is, right? So just some more special cases of factoring with a difference of squares or a perfect square trinomial.